Okay, mic check 1 2 1 2. Yo, Matt K, why are you always the first one on? That's crazy. Always, my man's chilling there by the PC, by his phone, on Baby's homepage. Like, is he gonna be live now? Is he gonna be live now? How about now? Can't afford DL audio. How's it going from Vegas? Okay, let's get this up and running. So, actually, what I need to do, it's been so long since I've streamed, I've bloody forgotten how to do this. Pop out chat and then shove that over that side of the screen and get OBS over there and put that there. And then hopefully the chat should pop up on the side. There we go, look at that. I've been good, thank you very much. That explains why that's usually over that side. Yeah, of course. Small that down a bit. There we go. Hello Robert, how's it going? How's it going Ray? What's up Aaron? What's up Sean? Cheers for jumping on. Alright, let's check all the cameras. We have overhead, we have scope cam, multimeter cam. Oh, it's working for once. I wonder how long it will stay working for. We'll have to wait and see. It's been a while, how's it going? Just going to let the stream pick up a bit and we'll get started on this thing. Today we are working on a Audiosystem X series amplifier. And this has come in from another technician. It has problems with one of the channels, so we're going to see if we can figure out what's going on. Just going to get cracking. Have you heard about these new Sound Digital GaN-FET amplifiers? Yeah, man. I have. Pretty exciting stuff. GaN-FET technology has the potential to create or to make available Class D amplifiers that are unfathomably efficient, super efficient, and also sound really nice because gallium nitrate, which I think is the stuff that's being used in solar silicon, can switch much faster than typical silicon MOSFETs and stuff can. So I think it's going to be pretty exciting stuff for high efficiency, nice sounding amplifiers. I don't necessarily trust Sound Digital to do it correctly though. After looking at some of their recent amplifiers that they've made, they've not been too great. Let's put it that way. So I am excited for GaN-FET technology, just not sure that Sound Digital are the ones that are going to impress me with it the most. Right, we seem to have a stuck switch first and foremost. Now, I was wondering if this is a preamplifier related issue on here. So if we zoom in down here, you can see that we have this switch which is for high or low. And when I push on it, it doesn't click in and out. It literally just sort of pushes in for a minute, then comes back out to its previous position. So I think that switch is buggered, and that might actually be affecting the audio because the contacts in there might be corroded or might have oxidization on them. It doesn't seem to work too well. So going on, Sunflower, how's it going? Hello from Ohio, Tony. The question is though, can I get this switch clicking in and out properly just by wiggling it with some isopropyl? It certainly feels a bit better already. What I don't really want to do is dismantle this switch, because these switches are a absolute pain in the butt to put back together. Here we go. Now we're starting to get some clicky action. You can probably hear the difference there. Now it's starting to click properly. So just some isopropyl alcohol and some working backwards and forwards, and that is now clicking correctly. It's going to spray some more ISO because the contacts might be kind of janky in there. Let's keep this going. Evening Zach, evening David. What makes a good sound quality amp? A few things really. Right, so generally Class AB generally sounds better than Class D. Not always. You can have a really cheap Class AB sound worse than a really good Class D. But the things that make an amplifier sound good are going to be things like channel separation. So that means that between the channels left and right, or if there's 4 channels, left, right, and rear, left, right, there's not any leakage between the signal going to each of the channels. So if you're obviously sitting in front of 2 speakers and you've got a nice stereo image and you've got different elements coming from each speaker that are creating that stereo image, well, having some of the sounds blend that are supposed to be in the right speaker, having them come slightly out of the left speaker can really mess up like a nice focused soundstage, nice focused image, and it can place instruments where they shouldn't be in the soundstage. So having good channel separation is one thing. Secondly, obviously having low THD is nice. Low THD will generally give a cleaner sound, less distortions, and instruments sound more natural, more lifelike. Having a low signal to noise ratio, that means that you don't get the background hiss when there's nothing playing. So that means that the signal is loud compared to the noise, signal to noise ratio. So you want a nice quiet amplifier. You've also got obviously frequency response, needs to be nice and flat. Yeah, pretty much just low THD, because the THD tells you how accurately it's really reproducing the sine wave. Low THD, nice high signal to noise ratio, good channel separation. Is DL a good brand? Don't know what DL, maybe you mean DLS. DLS is a pretty good brand here. Yeah, the amplifiers will sound absolutely fine. How's it going, Sonner? Sunflower Easy. Oh, Jesse's actually me, Jesse. I switched my name since I've been doing videos while having, oh yes, hiccup spasms. I remember you you sent me a link to that. Yeah, crazy stuff. How's that been going for you? I haven't actually checked out the channel in a while. Tony says I just had a Preamp MD12K repaired after it blew up and caught fire. That's never good. It's actually less common, believe it or not, for the Preamp amplifiers to like go on fire when they fail, just because they're controlled by a MCU that will shut down the power supply section when there's a failure, and also has a health check mode, so it won't start up the power supply if it detects as a failure. Whereas the old Koreans, the power supply has no protection against that, so they always like smoke up. What would cause a sawtooth waveform on the output? Depends on the amplifier, if it's Class D, Class AB. It could be a whole bunch of things, but it's likely to be drive circuit related. Okay, I think I've pushed this button in and out enough times now. That is now a proper clicky button. I'm also going to do the same to all the others. So you see these types of switches that you'll find on amplifiers, they actually get really bad contacts inside, and they prevent the signal from passing decently inside the switch. So I'm just going to take some isopropyl alcohol and spray all inside the switches here, and just click them on and off like sort of 20 or 30 times. How's it going, Damien? It's been a while. It has been a while. Oh, I've been doing good, and yes, it sure has been a while. So Jesse, so yeah, what's the hiccup situation like at the moment then? Is it like constant? Is it like every day you'll have these fits, or can you go like a couple of days where you don't get them? Or, you know, is it like once a week kind of thing, or is it like literally every day, quite all the time, you know, a few times an hour? How's it going, Kevin? I'm searching for a good solder fume extractor. Any recommendations? I am also searching for, well, I'm not actively searching, but I should be searching for a good solder fume extractor, because I don't currently have one set up. I'm doing the old gently blow the fumes not at my face, and if I'm doing something that requires a lot of soldering and a lot of the fumes, I'm sort of like deep breath from behind me, hold your breath while you're soldering, exhale, blow the fumes that way. Deep breath from behind me, because yeah, I need to sort something out. I need to 3D print a big flare, like a big nozzle or something, and get a big fan or extractor hooked up somewhere. JD Sound, you did catch another Bev is live, the first one of 2024. Sound Digital released some limited series GAN amplifiers before, but I hear they were more hybrid. Interesting, I haven't actually seen the details on those at all. Yes, it is daily and varies. It can be mild, and other times you can't stop. It's crazy. That is crazy. I mean, it sounds pretty bad. It sounds like it would be, you know, really annoying. But I'm sure there are worse things that you could have. If that's going to be your thing, if that's your thing, if that's your health issue that you're going to have, then sounds like really freaking annoying, but I imagine there's much worse things it could be. So today we're working on an Audiosystem X series. This is the large chunky long boy Class AB 4 channel. I'll show you the full board in a minute once I've finished cleaning these switches up. This has actually come in from another technician here in the UK who has done some work on it, but says that there is still one of the channels is still duff. Replaced a bunch of parts in the channel that was blown, but still not quite working right, so we're going to see if we can find out what the issue is. And my first inkling was preamplifier related, because I had a quick look over this board with my eyes, and it looks like the repair has been done really well. This technician's way more experienced than I am. He does fantastic work. Yeah, everything's been done properly. Obviously got all nice new parts in there and everything. Class AB is this gentleman's forte. He's very, very, very experienced in Class AB. So there'll be nothing wrong with the repair, I'm sure. So the fact that a channel is still bad kind of makes me suspicious of other areas. And when I looked at the preamp board, I noticed that one of the switches here was really crusty, and it wasn't actually clicking in and out smoothly at all. So I thought let's clean all these up first, and then we can investigate further and see whether we can find where the issue lies. So I've given all those a nice clean. I'm going to put the preamplifier daughter board back in place, and I'm going to power it up and see what it does. Okay, get in there. We just need to, now this is kind of tricky bit, because for those pins to go in there, we have to kind of, yeah, I don't know. Wait, how did I get that out? How did I get that out? Yeah, this is not going to line up. I think I might have to take the... I think I managed to just about get it out, but to get it back in again, I think I'm going to have to take the front plate off, because the pins are like a good 2 pins out, because they're at an angle like that. So I think we're taking the front plate off so I can get that back on. And then now for anyone that's just joined, you can see the full scale of this board. It's a long boy Class AB 4 channel. Should be a really nice sounding amplifier, this, provided it's biased correctly, which we'll do as well. So I need a Allen key to get the front plate off of this. Provided this is a front plate, it's not just one piece. Don't tell me it's just... Oh no! Guys, it's one piece. There is no front plate. Bloody hell. Okay. I might have made a small mistake then in taking that daughter card out like that. I'm sure we can get it back in by doing some creative lining up of the pins, but apart from that, the only other way to get this daughter board back in would be to take the whole board out of the case, which we don't want to do. Okay, let's have a look, see what we can do. I can pull the main board out, but that would be very time consuming, and there's really no need to. The main repair's been done. So with this, we need to get that in there, and that needs to go on there. So we need to angle that like that, But when we angle it like that, the pins don't line up, obviously, because they're angled. Now what you can see in there. So what we need to do then is to tactically bend a couple of these pins towards where they want to go, and then when it gets pushed into place, they'll bend themselves back. I also want to see if I can just bend the whole thing over a little bit. Let's see if that's given us enough. Oh wait, I think we're on the money here. We're so close. Just that last pin is just a millimeter more that way, and then we should be good to go. Greetings from Austria. How's it going, Samir? Samir, you share the name. You share your name with a very famous rally driver. Just to let you know. He's very famous, but I don't think he was very good. There we go. And then just this top one. There we go. Lovely stuff. We are back in business. No need to remove the whole PCB. Alright, so let's power it up and see if the repair from the previous technician is holding up, and yeah, see if we can figure out whether there's any bad audio coming from any of these channels. I'm going to turn my signal generator on, and I'm just going to go to the front of the board here, set some preamp settings. Let's have a little look and see what we've got over here. So we want to go into channel 1 and channel 2. I'm hoping we can clone those onto 3 and 4. So input mode, we're going to go for 2-channel input mode. I think, oh, there goes my there goes the snake cam as always. I still haven't soldered a proper USB onto that. In due course I will. There we go, it's back. Nope, it's gone again, never mind. So yeah, we have 2-channel mode inputs that should clone the signals onto 3 and 4. We have low input. Okay, have the gain turned down a little bit, just about a third there. And we have FSA. What is FSA? I don't know, but let's keep it off for now. And then we're going to have low pass filter. Oh, that's missing a little button there. That's how it came. So we're going to have low pass filter off and high pass filter off as well. So these knobs don't matter. Let's inject about 600 Hertz and let's see what we get on the outputs. So, power supply on. Does everyone notice anything different about the power supply? Although actually it's been like that in a couple of the videos now. Okay, start off nice and low at about 10 volts. And we have 630 Hertz going in, so let's power up. Let's make sure we don't get any DC on either of the any of the channels here. Okay, we have 1.3 amps of idle current draw, 1.4. Gonna zoom out a little bit on the scope, reject high frequency. So let's probe channel 1 first. There we go, there's channel 1. I think I need to source number 1, there we go. So that's channel 1, nice clean sine wave, all the way up to clipping. Channel 2. Where's channel 2? Channel 2 is not doing anything. Nothing on channel 2, okay. Channel 3 we have something. Nothing on channel 4. I wonder whether that's just because one of my RCAs is dodgy here. Or it might be that I need to put the RCAs into channels 1 and 3 in order to get output on all channels. 1, 3, no. Okay, let's go directly into 2 and 4. Ah, okay. Seems that we need to go directly into 2 and 4. Well, that shouldn't really be... Ah, hang on a minute. We have protection. The amp's just gone into protect as I turn the gain up then. It drew a bit of current there. Drew over 5 amps by the looks of it. Okay, let's go off and go back on again. So I'm just going to go with one RCA for now. So let's just go with this this yellow one here. Everyone loves the good yellow video composite cable for audio use. Right, so channel 1, we can go all the way up to clip point. No excessive current draw, no protect. Everything's okay. Channel number 2. Oh, okay, channel 2, that's where the high current draw pops into play there. And the amplifier almost wants to go into protect. Let's see if we can replicate that, just do it a little slower here. So, oh wow, okay, we have like 4 amps. Okay, let's remove the RCA. Okay, we are back to drawing 5 amps, which is the maximum I've got set without any RCAs connected at all. Do we get DC offset on channel 2 now, maybe? Ooh, okay, yeah. So now we've got excessive current draw. No DC offset on channel 2. Interesting, it seems to be like it's glitching around. It's not staying at 5, it's like jumping around. Any DC on... Ah, there we go. We have DC on channel 4. And I bet you that's the one. This is the one that was repaired over this side. Yep, there we go. Got a big jump to DC on channel 4 and a high current draw. So I think we need to investigate over here. Let's get the thermal imager out, because where we've got current draw like that, something's definitely going to be getting hot. So I just want to confirm that it is this channel over this side that's getting hot and that's drawing the current. Okay, nothing looks super toasty yet over that side. A little warmth on the heat sinks here. Again over here, a little warmth. So we are clamped to the heat sink, so I'm going to turn the current up to about 8 amps here, which should still be safe. And I'm just going to let the high current kind of sit in the board for sort of 10 seconds or so, and I want to see which ones of these heat sinks get toasty. Okay, we're back down to 1.4 amps idle current. Interesting. Does it stay like that? So we've got no DC offset on 1, 2, 3 or 4. Let's check for DC on the RCAs actually as well, which is double check. Okay, that looks okay. Right, so before it was channel, I think it was channel 2. When I plugged in channel 2 we got high current draw there. So I'm going to go back to 4 channel input mode, so I can put the RCA into each channel individually and just check each channel. So we have channel 1. Channel 1 has clean output. Okay. Channel 2 has clean output. Okay. Channel 3 has clean output. Okay. Now this is the one we're suspicious of. Channel 4 does have clean output, but notice the current spike as I plugged the RCA in. Did you notice that? The current spiked like up to sort of 8 amps there for a minute. I'm going to go up and down on the sine wave, and I'm going to see whether it suddenly starts to draw excessive current or not. No, seems to be behaving itself now, which is interesting. Okay. So is this like an intermittent fault? Let's go up to 12 volts. Okay. I just increased the voltage here from 10 volts to 12 volts, and now the current draw has changed. We're sitting at like 3.6 amps now. If I go up to, oh yeah, if I go up a tiny bit, like above it's all over the place. Okay, first thing I want to do is to remove all the bias from this channel over here. I'm going to zoom into the board over this side, because this is definitely the channel that we have issues with. So I'm going to knock the bias right back down to 0, oh, which it is. It's already on 0. Bloody hell, okay. Are all of them on 0? I'm going to knock the bias down to 0 on all of the channels, just from it, just to get the current draw as low as possible on idle. Right. So let's go on. Okay, so we've got 1.1 amps of idle current draw with everything on 0 on all the bias knobs. As I increased the voltage previously, I got a big spike up to like 8 amps, which I've not got anymore. Interesting. Let's increase the sine wave amplitude. Okay, that's now behaving itself. Ah, there we go. Amp just went into protect as soon as we put the sine wave up. So I'm going to go up slowly again, and we're going to see whether that protects again. Okay, now we have 6.2 amps of current draw. Definitely an issue on this channel then. I'm going to increase the bias slightly, because sometimes amplifiers actually hate being super underbiased. So we're going to go up on the bias potentiometer to about 1/3 here. I'm going to see if I can actually get it to a point where it's not doing the high current draw again. Here we go, 0.8, oh, 0.6. Okay. No, this is super unhappy. Okay, so you know what? This is definitely a drive circuit fault here we've got. It seems to be related to biasing, perhaps. Alright, so let's have a zoom in and see what components were replaced over this side by our previous technician. So we've got all new output transistors over here. We've got new gate resistors. The emitter resistor looks a bit crispy here. Looks a little bit like it's got hot in the past. However, it's a wire wound resistor, and it can get hot and be absolutely fine, still within spec. So not too suspicious of that. If that was bad, the technician would have replaced that, I'm sure. Let's just do a quick multimeter check. Yeah, that's still within tolerance, that's absolutely fine. So we've got Q417 replaced here, that's been replaced. These ones look original. This here has been replaced. This BCP56. We've also got some transistors over here, Q416. All these three have been replaced, as has the N5532 there. Okay. So the first thing I want to do, I'm a little bit suspicious of some of these transistors actually, because the markings on them, for example 2G, a transistor, a little surface mount transistor that's marked as 2G can actually have two different transistor models that have that same marking. I discovered that a few weeks ago while I was repairing something similar. I had a 2G transistor and I had the 2G transistor from the board, and one of them read as an NPN, one of them read as a PNP. Turns out there's two different models that both use 2G markings. So I'm going to go ahead and pull the transistors off that were replaced and just check them against ones from a good channel, just to make sure that they are the same type of transistor, and to check that they're characteristics are similar. Just going to clean off any of the flux that was on the board, because sometimes you can have as well flux being conductive and it can cause these kinds of weird intermittent issues like this. Yo DL, how's it going? I'll watch this later. Have a good one. Thank you very much, ma'am. Have a good day at work, buddy. Hope it's not too stressful for you. Well, I've cleaned off a bunch of the flux that was on there because there was some flux left over. I'm just going to power up one more time and see if that's made any difference at all to the regularity of high current draw on this channel. And I'm going to put the bias potentiometer way back down to 0 again. Channel 4. Power up. Okay, straight into protect that time. Okay, now we've just got masses of DC offset. As soon as we power up, loads, look at that, all over the bloody place. Loads and loads of DC offset. And all I did there was just some isopropyl alcohol and a bit of a cleanup. So, I'm wondering whether we have conductive flux left on the board or something like that, because just by doing a clean like that shouldn't have affected it that badly. Yeah, these emitters are still all good. So I'm going to turn my multimeter onto 20 mega ohms now, and we shouldn't get any resistance on the PCB itself, especially in this like flux area here. I'm just checking that the flux that's left on the board isn't like super conductive or anything like that. Oh, uh-oh, here we go, we've got something. Possibly. Did we get something there? No, maybe not. You can't see my multimeter because my the wire for it is broken that goes into the USB for the camera, but okay, now that seems to be fine. So let's power up and check that again. So now we've got high amounts of DC offset on channel 4. Not anymore. Now we have a sine wave but extreme current draw. So yeah, there's definitely a biasing supply issue there. Let's have a little probe around and see if we can compare the bad channel here with one of the good channels. So I'm going to zoom out a little bit. Okay. So let's take a good channel, for example, this one, and let's see what we've got on these two transistors and these two transistors and compare it to our bad channel. Okay, we've got negative 36 on that one, 0 on that one, and negative 36 on that one. This one should be positive, I imagine. No, nothing. We've got negative there. Nothing on that one. Negative 36. Negative 36. Nothing there. Actually, you know what's really interesting is that when the high current draw sets in, we actually get a voltage drop and some DC on the transistors of all the good channels as well. That might just be the bias supply kicking in, mightn't it? Yeah. So that seems to be normal. So what I'm going to do is pull off some of these transistors that were replaced and compare them to the same transistors from a good channel over here. So we've got Q317 and 417, and on the board that is marked as I think 3DW. Yeah. Whereas on a good channel we are marked as it's very hard to make out. .3G. So we've got 3G and 3DW. So let's pull these two and let's compare them in the transistor tester and see if they are the same type of transistor. Now the sine waves, Lowry, are all good because we do have a clean sine wave on this bad channel still, but the issue is an excessive current draw, and that's a biasing supply issue because the excessive current draw only starts when the bias is enabled. So we definitely have like a drive circuit fault or a bias supply fault or something like that. So I'm just going to start by systematically checking all the parts that were replaced, because I have had experience with these little surface mount transistors having slightly confusing markings, and what you think it is, it actually isn't. So unbased, that potentiometer sets the biasing level. So with a class AB amplifier, you have some of the transistors make the one half of the sine wave, the positive half, and the other transistors make the negative half of the sine wave, essentially. And there's a bit of a crossover between the two, and that bias potentiometer sets the amount of overlap between the two transistors. The more overlap you have, the lower distortion you get, but it comes with the cost of more heat generated by the amplifier and worse efficiency. Right, so the original transistor, which is here, I'm just going to go ahead and measure that in the tester. Wait for that to cool down. That's alright, no worries. You don't want to go messing with those potentiometers because they're very specific in when they need to be set. If you turn the potentiometer down, then you're just increasing the distortion of your amplifier. If you turn it up, then you are going to cause the amplifier to get way too hot and draw way too much current, and yeah, it's not going to be too good. There's like a perfect place it needs to be set, and if you turn it, then you're never going to get it back to where it was exactly without doing a proper biasing procedure with the amplifier, getting it on an oscilloscope or whatever to reset that BIOS. It's definitely not a problem on the preamp. Problem on the preamp would not cause high current draw like this when biasing enables. It's nothing to do with the preamp, my friend. Get your head away from the preamp. So the original part here, we have a PNP with a current gain of 813, it's pretty high. So let's pull that off and let's double check that we have a PNP part in the repair channel. I'm just going to drop some fresh solder onto the pads for that as well. Should make it a bit easier to go back on. So that was a PNP transistor, wasn't it, I think? Was it a PNP? Tell me guys, that was a PNP, wasn't it? So let's get this one that was replaced. There's 3DW. Yeah, it seemed a bit high, but that is a working channel, so... And what do we have here? We have a PNP and we have a current gain of 261. You know what I'm actually going to do? I'm actually going to swap, as I'm testing these parts, I'm actually going to swap them round channel per channel, you know, between each channel, because that will actually tell me, once we've finished testing all these, if they're all the same type of part and the technician hasn't used an NPN where a PNP is supposed to be, whatever, then if we get to the end of that and they're all fine, then we can test the channel, and if the problem has moved channels, then we know that actually it is one of these parts that's been replaced that's causing the issue. Seeing as we're taking them off the board anyway, we might as well do this while we're here. This light actually makes it be very difficult for you guys to see, but oh well. Trevor, you're barking up the complete wrong tree there, my friend. There's no potentiometers that adjust the rail. I don't know what you're talking about. These bias potentiometers, these are absolutely fine. There's nothing wrong with these. And even if there was something wrong with those, they wouldn't cause DC offset. They would cause the current to bounce around a lot. I can see where you're going with that, but it wouldn't cause any DC offset at all if the value of that potentiometer was bouncing around. So, next one down, these ones haven't been replaced. The next one down is this one, that one's been replaced. So let's go ahead and pull that one, and it's co-pilot over here on the good channel, so we can compare those two. That's a 2G. So we're going to test the good one first and see what it should be. Do you have a crazy amount of amplifiers queued up? Yeah, pretty much. I always have at least sort of 15 to 20. It's not a lot. I know some of the guys in the States that do amplifier repair have like 50, and they have like a 6-month turnaround. That's crazy. I guess that's because there's a lot more work in the States. But over here, I'm pretty much the only person in the UK doing car amplifier repair, like specialising in Class D car amplifier repair. There's one other guy that does some Class AB stuff, but he mostly does research and design now. So, given that I'm the only person in the country doing it, I don't have that much work stacked up, considering. Should the drive signal for the power supply on a sound cubed be perfectly square, or a little downward hook normal on the bottom? Yeah, a little downward hook is normal, that's fine. It's very rare that you ever find a drive wave that is like a perfect sharp square wave. Just because you've got lots of capacitance in the gate and trace and stuff that screw up the shape a little bit. So don't worry if it looks a little bit wonky, it's fine. What's up, Canadian? I'm good. Good, thanks. Okay, so the original 2G from the working channel, that is an NPN with a current gain of 568. Alright. Let's pull the one that was replaced, and that's an NPN. NPN. And this one's labelled 1B. So basically guys, lots of people have asked me about the Big Boss series from Amps. They're actually sending me a Big Boss to look at. So as soon as I've got it, I'll make a video on it so you can find out. But I don't know yet because I haven't seen it. But it's on its way apparently. Slowly making its way to the UK. So we had an NPN, and we also have an NPN here as well. So let's swap those two round. And continue with our investigation. And just while I'm here, I'm actually going to go ahead and refresh the solder on these other ones that I'm probably going to pull out because it'll make it a lot easier. Some fresh 6040 on there. Fresh. So let's drop the 2G over here into our bad channel, as that's the original part. And let's put the replaced 1B transistor over on the previously working good channel. And then we'll know if the good channel becomes the bad channel, we know that it's something to do with these parts that were replaced. There we go. Okay, the next one down is this one. This is a 3DW, and that should be replacing a 3G. Now we already know that that is a part that lines up with the original part, so I'm not actually going to check that one just now. And then we've got a 2G at the bottom here, and that one's being replaced with again another 1B, and we know that that one is okay and that lines up with the type of transistor that it should be. So I'm going to leave those ones there for now. Let's have a little I spy, see if we can spot any other parts. We've got a op amp here. This N5532 was replaced, and it's the same op amp as in a good channel, just a slightly different package. I've actually had bad experiences when replacing op amps. They are very, very sensitive to temperature. If you are soldering in an op amp with a hot air gun like this, yeah, they can just like poop themselves from the hot air. So I'm suspicious of that. But before we turn our attention to that, I just want to, because this channel had some failed parts, there's two original transistors, a 2G by the looks of it, and a 3G maybe here? Yeah, 3G and a 2G that are original just there. I'm actually going to pull those and just drop them on the tester just to make sure that they are okay and not weird values, because these transistors can read like they're okay in circuit but actually be completely messed up inside, and they won't be read by the tester properly. So I'm going to drop some fresh solder on the pads here. Helps if I turn my iron on, doesn't it? Have you touched on the Tony Demore cleaner amps? No, because we don't get them here in the UK, unfortunately. So unless Tony wants to send me one for free, which he won't, then I won't have any opinion on those. Because yeah, we don't have a Demore. Well, actually, maybe we do have a Demore distributor in the UK. There's a guy that brings in some SMD Demore stuff, but yeah, there's definitely no Tony Demore amps in the UK that I'm aware of. So this is the 3G we're pulling first. Just going to check this one in the tester. I suspect these are probably fine, but it's better safe than sorry. We don't know anything about this amplifier or how it failed because it's coming from another technician, so we just have to kind of be suspicious of everything at this point. Alright, it's cooled down enough. Let's give that a little test. So this should be reading as a PNP, I think. Yeah, there we go. PNP 792. That's very, very similar to the one from the good channel, so that's probably absolutely fine. And then last one to check is the 2G just below it. Like I say, I suspect these are fine, but we have to be suspicious of absolutely everything on this channel at the moment. There we go. Drop that on there. Wait for that to cool down. So this is a 2G, so I think this should be a PNP. Oh, it's an NPN. 2G. Oh no, NPN was correct, yeah. So that's reading just fine as well. So these are just fine, no worries. So the first thing we're going to do now that we've checked all these parts, and cross-checked them with a good channel, made sure that they are the correct type of part and that the markings haven't got mixed up. Because we've been doing some heating of the board and swapping of some parts, I'm going to go ahead and power the amplifier up again just to see whether the fault has changed at all. If the failing component is silicon or if it's a capacitor, then by heating the area or the component you can actually change how it's behaving, and that might change what kind of fault this amplifier is actually showing us. So what we've done so far is just changed a couple of the replaced parts with a couple of known good originals from a good channel and heated the board a little bit. So let's see whether the fault is the same, different. So we're going to go for a little bit of power. The board now has some heat in it, so the components will be slightly warmer, so their values will slightly shift. Before we were getting a bit of DC offset on the speaker terminal here for channel 4 when we powered up. So let's power up and see what we got. Oh yeah, loads of DC offset still, so the problem is still the same. The problem is still on channel 4. This time no DC offset, but we got the crazy current draw again. So yeah, the issue is still pretty much the same. Okay, let's power that off. So this transistor here was replaced as well, but to be honest, I'm not really too suspicious of that. I am most suspicious of this op amp. Like I said, because they are very sensitive to heat from the heat guns. So what I'm going to do is I'm actually going to try to swap this one here with this one here, and I'm going to try and do so in a way that minimizes the amount of heat that the op amp receives. I'm going to use the regular iron, I think, and I'm just going to flood the pins a little bit on this side and then lift it up, try and get them disconnected from their pads, and then do the same on the other side and just pull it off, and that will minimize the amount of heat on the actual die of the op amp. There we go, lift it up that side. Let's go over here, do the same over on this side. Might need a bit more solder over there. Oh, there we go, it came straight off that time. Fantastic. Okay, that's nice and easy. So we have one removed op amp, and I'm going to go ahead and do the same to one of the op amps on the good channel. The only op amp on the good channel here. Okay. Actually, you know what might be interesting too, actually, before I do that, power it up without the op amp actually even in the board and just see whether we still have DC offset. We'll see whether the current draw is still there, because that might tell us a bit about whether the op amp has anything to do with this failure. Let's power it up and just see what it's like. I have no idea how the amplifier is going to behave with no op amp in. I don't think I've ever tried this before, but we've got a current limiter, so we should be alright. Okay, we still have the swing there to DC. Okay, and does it change at all? Does it DC is still all over the place. Okay, so that is still all over the place. But this time it's all over the place before the bias even kicks in. Interesting. Interesting. I think I'm still going to swap the op amps around anyway. Do you use an isolation transformer when you use the DUT? What the heck is the DUT? Digital... the DUT. If so, do you put your oscilloscope behind the transformer? Oh, device under test. Of course. No. Basically, no. The reason I don't use an isolation transformer, a couple of reasons. Firstly, is that because I'm working on car amplifiers that have a low voltage input and a negative ground. The negative ground from my power supply that runs the car amplifiers, I tie that to my ring main ground for the mains ground. That means that I can probe things with the oscilloscope probe without needing that pesky ground clip thing tagged on somewhere and restricting me from testing these large circuits. That does mean that my measurements on the scope are a bit noisier than they should be, because the ground path is quite long through the power supply, through the ground on the back of the scope and to the measurement circuit. However, because I'm generally measuring pretty high voltages, the tiny amount of noise is actually barely visible on the scope screen. If I ever do need to make some really critical measurements of very, very low voltage signals, then I grab my crocodile clip probe clips thing and put it on a ground reference on the board nearby, and that completely cleans up all the noise. Yeah, it's just a convenience thing, really. The only time that I would need to have my oscilloscope on a isolation transformer is if I needed to measure something, some waveform, where its ground reference wasn't like ground, wasn't 0 volts. For example, mains voltage power supplies on like amplifiers, like if an amplifier has a mains power supply, like a switching power supply, then yeah, there's no real way to scope or probe that with the oscilloscope how I have it set, because the ground reference that the scope would need would actually have potential on it. You have high voltage potential, so I can't go ahead and connect my scope to that. It would just like literally explode. So an isolation transformer would be useful. Trevor, it's not the resistor. Please. Please, Trevor. Somebody tell Trevor that it's not the resistor. I've explained it before. Anyway, let's get this op amp removed. Let's pop it onto the bad channel just to see what happens. I am curious. What we are dealing with is a drive circuit fault, possibly even I haven't checked the output transistors. I just assume that they've been fitted as new. As if you're just joining me, this amplifier has come in from another technician that was having some problems with it. So, okay, now that we've got the two op amps removed, let's go ahead and drop some flux on there. And just smooth out the pads, get them nice and cleaned up. I'm sorry the lighting is so bad on this camera, by the way. It's the reflection of this bloody lamp. It's not ideal. If I turn it off, it's kind of a bit better, but Trevor, it's fine. I promise you, it's not the resistor. The reason I know it's not the resistor is the resistor, changing the value of the resistor changes the bias position. Okay, changing the bias position won't cause DC offset to be on the speaker output. So if the potentiometer was bad, it would be drifting in value, or it would be not making a solid connection. And if that was the case, then the bias point would change and the current draw of the amplifier would go up and down all over the place, but it wouldn't prevent a clean sine wave, and it wouldn't cause there to be DC on the speaker terminal. That's a drive circuit fault or some issue with the output transistors or something like that. So that's why we're chasing those issues. Like I say, the reason I'm doing this with the regular iron rather than the hot air is that op amps are super sensitive and delicate when it comes to temperature, as I have discovered many times, and many wasted hours chasing my tail, only to find out that the brand new op amps I was fitting were dying every time. Okie dokie, let's clean that up and let's just confirm that the issue is still there. I kind of want the issue to still be on the same channel. This is an interesting one. I don't get a lot of weird issues with Class AV drive circuits, so this is kind of exciting to try and find the problem with. If you ever want to know how to get to me, right, then just be sad. I can't deal with people being sad. It makes me feel bad. So when Trevor sent the sad face, I was like, all of a sudden I was like, oh no, my heart, don't be sad, it's fine. Right, I'm actually just going to pull the clamps off of these output transistors just to see what's been fitted. Just in case we're like looking at the drive circuit when really the output transistor's like something completely fucking wrong or something, I don't know. I need my bigger Allen key. There it is. Right, what do we have? Actually, what's this? I'm sure these are genuine parts, but the font looks a bit interesting, a bit different. Actually, are they genuine parts? I'm sure they are. My man G wouldn't fit parts that weren't genuine. I'm sure they're genuine. He knows loads about fake parts, but the font just looks a bit sus. I wonder if I can show you. I wonder if I can show you this on the camera. I probably can if I get the hat cam. Gonna grab the old handheld cam to show you what I'm looking at here. But it might be worth actually swapping these parts round, the output transistors, just to see whether that's anything to do. Logitech Streamcam, where are you? Nope. Webcam. Doesn't seem to be coming up on the software here. And it's actually Windows isn't even recognising it, so maybe it's not plugged in at the back. That's annoying. Not to worry. Let's see if I can show you it on the big camera. Okay. So these are the original FETs that the amplifier uses. So you got IRF 5210s and IRF 1310N. That's original parts. So over here on the channel that failed, we have these three, which are original by the looks of it. Although they do look like they've been replaced. They're a different batch actually, so they might not be. But then these ones, the font is like very, very different. Like, they don't really scream fake to me, but they do look very... I've never seen a font like that before really, so... Still interesting. So now we've swapped the op-amp round with a good channel. I just want to see if that's made any difference. I suspect probably not, but let's just have a look and see if that's made any difference. So we had DC offset on channel 4. Just checking everything's okay. Checking I haven't made any solder bridges or knocked any parts off. Nope, good to go. Okay, power up. Okay, yep, channel 4 still absolutely horrendous. Big DC offset and a big high current draw. I'm just checking channel 3. Channel 3 is still good. So that op-amp, absolutely fine, no issues there. Okay, so drive circuit wise, everything seems to be kind of okay. I'm going to go ahead and plug in my camera for the multimeter because that's going to be important for this next part. You're going to want to see what I'm doing. If you're even watching and paying attention, I don't know. Maybe you guys are just here for the vibes. Maybe you're kind of interested in what I'm doing. I have no idea. But for the couple of people that are interested in what I'm doing, you're going to want to see the multimeter cam for this. So let's get that in there. Let's try and activate it again. There we go. Okay. So we obviously have some kind of drive circuit fault or some kind of output fault. So what I'm going to go ahead and do is compare multimeter diode mode readings between the same transistors for each channel. One of the good channels and one of the bad channels, because that will kind of maybe tell us where the issue might be lying. So let's just start randomly up here. We've got Q417, so we've got 616 over there. So let's go to this side. This is the same transistor, 600 and 730. Okay, nope, same on that side. So that's good. We're looking for something that's very different between the two channels here. 300, 300. Flip the probes around. When you're on diode mode, the orientation that you have the probes actually makes a big difference. Okay, no, that's about the same on that transistor. So let's move down to the next one. 584, 585, 581. 583, yeah, that's looking fine, that's probably fine. 687. 706, slightly different there, but I think we have a different transistor model. So, yeah, there's a slight difference there, but I think that might just be to do with the transistor model being slightly different. Where when we flip the probes this way around, we're climbing up to about 1,000, and still going. So I just want to make sure that's the same over here. Make sure we don't get a fixed value. Yeah, still going. Okay, that's probably fine. The 2G at the bottom here. 800 down there. 800 down there. Yeah, that's pretty fine. 581. Okay, let's just try over this side with the 1B. We've got 597. 612. Similar enough. 614. Similar enough. 611. Yeah, similar enough. 1321. Yeah, it's about the same. A couple more to check. 612. About the same. 1000 and climbing. 1000 and climbing. Yeah, I think that's all probably fine. Let's check some measurements between the op-amp pins. So the outer two pins 1 and 4, we have about 614 there. About the same there. These ones 6, 5 and sort of climbing. About the same there. 693. Yep, it's about the same. 16. Okay, that's something that's a bit different, but that could just be because these op-amps are different. So we have 1247 between 6 and 7, whereas over here we have 1386. Oh, it's kind of similar-ish. That's probably fine. Okay, let's try these output transistors then, the output MOSFETs. So we got 655, about the same. 648, about the same. No shorts. Gate resistances, we have 86, 29. Hang on a minute, is the gate resistor a lot different there for one of those? Interesting. So the gate resistors for the 1310s are, we've got 85, 86 on the multimeter. The actual value will be slightly different because I'm still in diode mode, so it doesn't read resistances accurately. In this one, we've got 29, 29, 29. So it looks like we have a slightly different value gate resistor for the N channel and the P channel by the looks of it. Yeah, that's fine. Okay, so I'm not really seeing any variances or differences, to be honest, between these two drive circuits so far. Ah, there's something here that's doing quite a lot different actually. Or maybe not. Just wasn't touching properly. So, I'm going to try swapping the output transistors here that look a bit strange on the font with the ones from the good channel, just to see if that makes any difference. I'm also going to drop in the transistor tester just to see what their specs look like versus the original ones. Let's pull these out, fresh solder on the pins there, lock it on all three and just pull it out. No need to dismantle the board from the heatsink in this case. Everything's super accessible from the top of the board. There's one. There's two. 3. Okay, fantastic. And I'll do the same with the 3 good ones on this good channel, channel 3. One, two, three. I'm also wondering whether to pull these 5210s. Just going to check the batch on them. DS61. So now those are replacement parts. That should be fine. They're the same font as the originals, etc. So I'm not at all suspicious of them. Not really suspicious of these other ones either, but they do just look a bit different to what I'm used to seeing. So let's drop them in the tester. Let's see what the tester has to say about them. So we've got VT of 3.5 volts, gate capacitance of 4.89. So let's check all 3 of them. Yep, that's the same. That's the same. So we're looking for a similar, the VT can be different, but we kind of want the gate capacitance to be about the same. The reason I'm blowing on it is the temperature does actually make quite a big difference to the specifications here. Yeah, that's about the same. So I'm not really very suspicious of these parts. That seems to be fine. I'm going to swap their locations though anyway, just because we might as well. We've taken them out, we're swapping locations. If the problem moves channel, then we know that we've struck gold. That's those 3 cleared. Let's do these ones in the corner. Yeah, this tester's been with me for, it's got to be 6 years now, maybe longer. I did actually have to repair it once though. Interestingly, it did actually fail one time. But it's been pretty sturdy ever since. It's very cheap, and it's actually honestly been a lifesaver. That tester has helped me find so many faults in the past that I would have missed with a multimeter or wouldn't really have known about. Or really good little tool, that. Okie dokie, let's put the original looking ones over here in the bad channel. To be honest, there could actually be, I don't know how badly this this amplifier failed, like how dramatically it failed, because it's been repaired before it came to me. It might be worth having a little look on the back of the PCB, just in case there's like a blown trace or something on the back there, because I don't know for sure, but I imagine that the other technician that repaired this may not have actually stripped the board from the case, because everything's very accessible from the top of the PCB here, and there's lots of flux on the top of the board that suggests it was a top board repair, like kind of how I'm doing now. So if the board was never taken out, then chances are they may have missed like a blown trace or something on the back of the board. So if we get really stuck with this at some point, then I guess we could pull it out the heatsink. It is kind of annoying though when you take the board out of the case when you don't need to and you find there's no problem. It's like, oh, waste of my time. It's like, urgh. See, I knew this one was going to be a little bit of a pain. That's why I chose it for the live stream. But I'm not the biggest fan of working on Class AB. Give me a Class D any day. I freaking love working on Class D. Class D is much easier to kind of follow the issue through the circuit. Class AB, I find is much harder to do that, because Class AB kind of relies on current levels rather than voltage levels. And voltage levels are much easier to just quickly see with your scope or your multimeter, whereas amount of current going into the base of a specific transistor or op-amp or whatever is not quite as easy to instantly check. Right. Let's give that a little blowout. So I suspect the issue is still on this channel. So let's just blow off that isopropyl alcohol for a minute and confirm that is the case. Oh, there's one biscuit left. Okay. So let's power up. Do we still get DC offset on channel 4 and high current draw? Make sure that the bias potentiometer is nice and low. Yep. Big jumps and swings on channel 4. Let's just check channel 3. Yeah, channel 3 is alright. 5.6 amps. Woo! Something was getting hot enough to make a little sizzle sound there. with only 5 amps going in. Let's have a look with the thermal imager and see what it was. Was it one of the output MOSFETs perhaps? Or was it a smaller component? And the sizzle was just the isopropyl alcohol burning away. Okay, look at that. We have very, very toasty output MOSFETs. And that is these 5210s here. Interestingly, only 2 of them. So I'm actually a little suspicious of them. Maybe I should pull these ones, these 5210s. Now it seems that we just get a big... Oh, we get a big DC offset to positive now. And what's interesting is that there's nothing on the gate of the MOSFET to suggest that it should be like turning on like that. Like, these are MOSFETs essentially, right? So basically this is on the drain of the MOSFET, like big sort of jumps around to DC and stuff like that. If I probe the gate just has a nice smooth ramp up to positive there, which I think it should have. Yeah, it's the same as on the good channel. So I'm just going to use another oscilloscope probe here just to compare what's on the gate of that MOSFET compared to one of the ones on the good channel that's not giving us DC offset. So I wonder whether these FETs are just like stanky. Right, let's go on to here. Yep. 10 volts divide. Let's just put both probes on the same part first of all, just to confirm that the probes are kind of calibrated the same. Yeah, okay, so that looks like one line. So now if I go ahead and put one of them over on the good channel. Ah, no, they are actually slightly different. We do actually have slightly more gate drive on this one here that's bad. Yeah, so I think maybe the FETs are actually fine. You can see that we've got way more gate drive on this one here. So that tells me that there's an issue with the drive circuit driving the 5210s. Let's confirm and compare that with the 3110s over here. Let's compare what we got over there. Okay, the 3110s, no, is absolutely fine. So comparing that to a good channel, we have the same voltage basically on the gates of both. So that's not a problem. Problem is on positive side here. Yeah. Okay. So that's where we need to be turning our attention to then, gents. Is the drive circuit that feeds the 5210s. And that's going to be these guys. Right, so let's get the multimeter out and let's start comparing some readings between good and bad. I'm not actually a fan of coffee. I'm not a fan of caffeine. Caffeine doesn't really sit well with me. I find that my brain is already firing off on all ADHD angles. As soon as I put coffee in my brain, it's like it's too much, and I actually lose the ability to focus and do stuff because it's just too much. Too much stimulation. So, problem on the drive circuit for these. So let's follow the gate back and see what drives the gate directly. So let's go for this one here. Got the gate resistor, then we go down to here. Okay, we've got this resistor and this resistor. That is a very low value resistor by the looks of it. That is the fourth component down. Let's confirm that on a good channel. 29. Yep. Okay, so let's check a few resistor values then. So this top resistor here should be a 220. Let's go ahead and change the multimeter to read stuff properly. Oh, and it's glitching around again, which means I need to clean up the old contacts on the USB. There we go. Is it going to come back? Oh, no, it's really bad. Delta, thanks for jumping on, man. I appreciate the kind words there. Glad you're enjoying the content. The emitter resistors look like they need more solder. Yeah, no, they are very, very, very soldered on the bottom. But I do understand what you mean. They look like they're not soldered very well on the top, but they're very soldered on the bottom. I can guarantee you that. So we need a 220 up here. Let's check that. 219, that's pretty much within spec. Let's move down to the next one. We have something too high for the meter to read. Let's change the... we have a 12K. Let's confirm. Ah, I think, amigos, we found the problem. I think we found the problem, guys. So, on a good channel, we have a resistor that's under Q317. That is, what is that? What are you? 18.3? What's my test lead resistance? Test lead resistance is 0.4. So that's going to be like an 18 then, I guess. 18, 17.9, 18? Yeah, it's going to be probably dead on, yeah, 18. So we've got an 18 ohm resistor underneath Q317. Now, if we go along to this side here, this resistor is reading 12K, or open on this setting. So that is our problem. Just my guy... I should have checked all the resistors first, I know. Usually resistors, when they fail, especially low value resistors like this, they show a visual sign. They look a little bit burnt, or they have a little dark spot on them, which it didn't. So all of that swapping around components was kind of a waste of time. But the problem is, when you get an amplifier from another technician, especially one that really, really knows what they're doing, you kind of approach a repair in a different way. Like if the amplifier came in, that channel had been blown or whatever, with a bunch of blown surface mount components around here, as you're replacing all of these, I probably would have just gone through and checked all of the low value resistors, because it's kind of what tends to fail the most often. This part here was replaced as well, so I think I just kind of assumed that all these resistors had been checked, where they hadn't. So that's our problem. That's why this amplifier is doing nonsense. So let's go ahead and pull that out. And now, gents, I've got to see if I've got any 18 ohm resistors laying around. That's a very strange value. If I don't have an 18, for the purposes of this live stream, I could either do a stack job, a couple of parallel resistors to bring it down to 18, or a series job or something, just to show you that that fixed it. So let's have a look in my drawer. It's greater than 10 ohms. This is my greater than 10 ohms drawer. So let's have a peek. What do we have? We have some 10s. We have some 22s. We have 68.1. 47s. 10s. That is 56. 10s again. 33. I just know I'm not going to have an 18. 47. 47. That's a 13. 13, 14, 15, 16, 17. I could probably get away with a 13 and a 4R7 in series, but I got a 15, but no cigar, and a 20. Classic. Right, just for the purposes of this live stream then, let's see if we can stack a couple of resistors to get us our 18 ohms. So, let's go to parallel resistor calc. Yes, you can have my cookies, no worries. So, let's start off with, so what have we got? We know we've got a, let's start off with a 47. Got a 47. Let's do a 22, see what that comes out. 14, okay. So let's try a 47 with a, I think I had a 30. 18.3, that would probably be absolutely fine. So 47 and 30, let's remember that. What other ones did we have? We had a, we've got lots of 10s, but that's not going to be any good because that's below the number that we need. So we need above 10, 10. That's a, I've got a 56, there we go. Hang on, how about a 56 and a 22? Got loads of them. No, that's a bit too low. Got a 15, that's too low. 7. How about a 50, what about a 56 and a 30? That's going to be too high, isn't it? Yeah, it's too high. 22. 68.1, 68.1 and a 22. Bit too low. I think the closest we're going to get is, oh, is it a 33 I've got? Hang on a minute. It's, what was it, a 56 and a 33. Ah, it's a bit too high. Oh, it's a 47. 47 and a 33. That's a bit too high. I thought I had a 30, or was it a 20? 10, 22, 13, 47, what a 20. How about a 68.1 and a 22? Did I do that already? 60, that's too low. What about a 100 and a 22? Ah, there we go. That's nice, easy numbers. 100 ohms and a 22. I don't think I've got a 100 ohm in my drawer here. Oh, maybe I do. Yeah, I think I do have 100 ohms. So 100 ohm and a 22 brings us down to 18. Spot on. I'm going to load that in for you just for now, for the stream, but I'll probably drop a brand new 18 in once I've ordered them before this goes back to the tech. But just for the purposes of this stream, my hundreds, here we go, here's 100, 100. Do I have any smaller hundreds? Because they're kind of big. They're kind of chunky. Another 1, would you? 3, no, that's fine, I'll just have to use that, that's fine. I've got 180 ohms, which is almost 18, just too many bloody zeros. Sweet. So we've got some 100s and we've got some 22s. That'll do just for now. So confirm that that's the only problem left with this amp. And then you can see me bias it. And actually, you know what? The amount of people that ask me how to bias an amplifier, I need to just make a dedicated video on it, rather than doing it in live streams and then trying to link them to this random point in a live stream. Oh, 56 times 3, Gary says. Hadn't thought of that. Let's try. Obviously, not ideal to have to stack many, but let's just try 56 by 3. Oh, it's close, but the 100 and the 22 is the closest we're going to get. That was like 18.0 something, wasn't it? I think. Can't use a variable resistor. I could use a variable resistor, but I don't have a surface mount variable resistor that's that small, and it gets a bit sketchy wiring, like soldering big leads onto tiny surface mount pads. Like, it would be fine. I'm sure I could do it just fine, but I don't want to risk damaging the pads for whoever owns this amplifier unnecessarily. Like, stacking 2 surface mount resistors, not going to damage anything, but potentially hanging a great big potentiometer off of some tiny surface mount pads could, if I knock it or something, there's a small chance there that that it, you know, causes some damage to the traces, which I don't want to do. So, right, how zoomed in can this camera go now? Let's have a look. Where are we? Yep. Doesn't like to go that zoom. There we go. Not too shabby. So let's drop the 100 on first. Now I'll show you a cool little trick for stacking surface mounts. Makes it a lot easier. So we're going to put the first one on like that. Okay, easy, easy. Now, with your hot air gun, still, take your wire of solder, okay, and you're going to heat the solder joint and just push a little bit of solder into it. And that will create this little raised bump. Like that, and like that. There we go, and I'm just going to push that down, and that will allow you enough solder above the resistor to place a second one. Touch more flux. There we go, lovely jubbly. Muy bien. I like. So once that's cooled down, if we measure that with the multimeter, we should get pretty much spot on 18. And I'm just going to go ahead and check a couple of the other ones as well, because if that one was dead, then who knows what else is dead. So let's go ahead and confirm. So we should have another 18. There's another 18 on the good channel. Let's just check this 18 here. That's 18.8, but it's very hot, so the resistance has gone up a little bit. That is 1,000 ohm, should be. I suspect that's fine. There we go, 1,000 ohms. We should have 1,000 there as well. Yep, and 1,000 there as well. Let's just check the 18s on the other side over here as well. 18, yep, and how about there? 18. Yeah, cool. Alright. Let's clean off the flux a little bit. Where's my hammer? No. Don't want the hammer. We want this. No, long time no ABC. I love that. That's actually really cool. I'm going to start using that. Anyone happen to know what the PS gate pull down resistor values are in the Preamp MD8000? Not off the top of my head, but you could probably just use 1,000 ohm, 10k, doesn't really matter. It's just to prevent there from being any charge build up on the gate while the amplifier's off. Stops the power supply effect spontaneously turning on. We are in a group now on a discussion about slew rate, and we tried to find a comparable testing range to compare amps. Do you have a rough indication for us? No. Easy answer. I don't really know what the slew rate is, if I'm honest. It's not really something that I tend to look at or pay much attention to. Okay, so hopefully that's got rid of our DC offset and high current draw, and we should be able to bias all 4 channels now. But let's just see. Oh, hang on a minute. There's a 102. Where's that 102 come from? You cheeky bugger. That must have fallen out of one of these little strips here. Don't want you floating around inside there now, do we? Right, so give it some power, turn that channel off, 10 volts. Okay, there we go, that's much better. So no current draw, we've got 1.2 amps, sorry, 1.2 amps of idle, no DC offset on any of the channels anymore. So we're going to go ahead and bias these up. But in order to do so, I do need to clamp the MOSFETs back to the heatsink, because their temperature versus the bias sense thing and everything is very critical, so we don't want them getting hot while we're trying to bias it. Yeah, sorry Chris, for not being able to give you any more info on that one. But yeah, it's not really something that I see people compare against or take much notice of. I don't really see it listed as a spec in a lot of amplifiers that I look at, really. I could do a quick Google of it, and once I understand what specification it's trying to tell you about, I could probably tell you a lot about it. Or what characteristic it's trying to tell you about, I could tell you all about it. But first of all, let's get this biased. So we're going to go in with our RCAs. I'm a little bit confused why we weren't getting channel cloning going on. When I had this set to 2-channel input mode, I should have got an equal sine wave on all 4 channels when I had it set like this, but that wasn't the case, which is a bit confusing. Anyway, let's power it on and let's get a sine wave on the channels first, and then we will be able to bias it. Actually, no, I'm just going to bias it one at a time. Okay, let's bias channel 1 first. So we're going to go ahead in 4-channel mode, get our little screwdriver here, and I'm going to power up. Make sure we have a nice clean sine wave to start with. Okay, we have something horrendous on there. Is that because the bias is down? Okay. Why does that look like junk now? That was fine before. That actually does look like preamplifier related, possibly. Ah yes, that's preamplifier related. The one switch I didn't clean is very, very dirty inside. Right, let's try and get some isopropyl in there. You see how I called that straight away? As soon as I saw the shape of that sine wave, I was like, that looks preamplifier related. Let's try and get some isopropyl in that and give that a... Don't cry, it's okay. I don't want to take that daughter board out again, because that was annoying, having to bend those pins to get that to go back in. Spray a little bit in there. It was an audiophile obsession in the 70s and 80s. In that case, it's probably not relevant anymore. The speed of transistors, MOSFETs and stuff has gone absolutely through the freaking roof since then. So I suspect it's probably a bit like damping factor. Damping factor is probably not relevant anymore for most things. Okay. Right, try that again. So, power up. Should get a nice clean sine wave. There we go. Now what we want to do is we want to turn that sine wave up to 20 kilohertz. So let's get that nice and low, times 10. Let's go all the way up to 20k. Yep. There we go. Now what you can see here on the scope screen is a pretty bad, horrendous amount of crossover distortion. So you can see there at the top and the bottom of the sine wave there is a big lump. And that's because the amplifier has a large gap between the two different types of MOSFET turning on and off. And we can give them a little bit of overlap by increasing the potentiometer on that channel. And you'll see that the lump will start to go away and the current draw will slightly increase. See that? Lump's going away, like that. And the current draw, we're at 1.4 amps idle at the moment. I'm actually going to go up to 14.4 volts to set the bias here, and we're going to go until the bump visibly disappears and we hit 0.1 of extra idle current, so that shows we've got a good little overlap. There we go, 1.6, spot on. So let's do the same on the next channel here, channel 2. Just pop that in there. As you can see, nice big bump on the sine wave, so we're going to increase the bias until that goes away and we get 0.1 extra current draw. That shows that we are overlapping. There we go. Looking good. Channel 3 now. Okay, the gain is slightly higher on this channel, so it's going to go down a little bit. So again, increase the potentiometer, watch the bump disappear. I'm going to go just below 2 amps on this one because there was it was sitting basically right on the 1.9 already, so there we go, just under 2 amps. And then lastly, our bad channel, channel 4. Hopefully we get a clean sine wave and no high current draw. Lovely stuff, fantastic. Okay, so let's go and get rid of that bump and maybe 2.2. There we go. Lovely stuff. And that is one 4-channel Class AB amplifier all fixed. Hey, Matthew's in the chat. How's it going, my friend? Fucking crank it up to Class A. No. You get like 40 amps of idle current draw. Hamilton, it's good to see you online. Good to see you in the live chat as well, my friend. Thank you for jumping on. It's always good to see. Good to see names I recognise. Do you think that old devices with a low slew rate would have a vintage sound? I don't know, because I never really looked into much what slew rate is. Probably because I was born in the 90s and it was kind of irrelevant by the time I was born anyway. No idea. I suspect that a vintage sound is actually a even order harmonically distorted sound, which you can replicate with plugins or effects if you want to. All these people using valve or tube amplifiers because it sounds warm and fuzzy are just introducing even order harmonics to their music and distorting it on purpose, spending thousands of pounds doing so, and if they really want that effect they could probably just run it through some kind of effect thing that gives it the same sound. And if you want to get the amplifier to me, you need to live in the UK. If you do live in the UK, then no worries. Ah man, thanks for the $5, my man. Hamilton, chasing amp problems for 2 years. Problem was low voltage. Oh damn. Should have been your first your first thing to look at, my friend. But I'm glad you found the issue at least. YouTube does not provide steady hands. Oh, you are in the UK? Yeah, drop me a message then. Facebook.com/bearvids. Drop me a message on the old Facebook page and I will get back to you on that and get your amplifier sorted for you. Right, let's have a look at something else. Oh guys, what should we do now? I've got a couple of interesting ones for you. We can either do an Audiolab 8000S, which is a home integrated amplifier. It's like a really nice, like, I think it's built in the UK or designed in the UK or something. It's like a home audio hi-fi amplifier that's fucked. It's like all the resistors are burned, everything's fucked. Or we can look at a Teramp's MD5000, I think it is. That has one of the rectifier's legs exploded. I haven't gone any further with that. Just saw that and was like, huh, that's fun. We can look at, what else we got? Got some Helix amplifiers. A Helix DSP and a Helix amplifier, both sent in at the same time because the DSP wasn't sending anything to the sub-amp and they wanted me to look at both. So got that I could look at. What else? Got an inverter, a mains inverter that runs on 24 volts. So I need to fit some new IGBTs to. I think that's probably about it for tonight that I can just quickly grab. Yeah, let's do the Audiolab. Let's do the Audiolab. I think I have actually started working on it already. So you're not. I don't think you're going to get to see the burnt resistors. Maybe you will. Well, here's one. I already took all the burnt resistors out of the Audiolab, but basically there was like a load of resistors that all look like this. And actually the board looks really burnt. So you'll see the burnt board. So yeah. Did that DAC chip arrive, by the way? Nah, it's coming from China, so it's going to take some time. I'll let you know as soon as it does, but it's usually like a good few weeks. Trevor says, oh Trevor, don't do that to my heart, man. Trevor says, sorry for my bad advices. Dude, it's cool, man. I'd rather that you chimed in and gave advice, even if it ultimately wasn't the right advice, because actually, to be honest, Trevor, your thought process wasn't like terrible. Okay, the current draw from the amplifier was like spiking around all over the place, and we did actually for a little while see a clean sine wave on channel 4. So clean sine wave, current jumping around all over the place. We had bad switches in the preamp, which suggests that oxidization of contacts has occurred at some point. So it's a pretty sensible suggestion there that the potentiometer for the bias might actually have bad contacts. That's not a bad suggestion. The only thing that told us that that wasn't the case was just that there was DC on the terminal, and that was the only thing that told us it wasn't the bias potentiometer. But everything else about how this amplifier was behaving, yeah, could definitely have been a bad potentiometer in the bias. Don't think I've ever seen that happen before, but it definitely could happen. Okay. Oh, that was pretty cool, yeah. My guy here in the live chat, Matthew, brought me over a DAC, like a USB DAC, that it only worked after like half an hour. So you plug it in, Windows wouldn't recognise it, nothing. But then you left it plugged in for like half an hour, and all of a sudden Windows would be like doo doo doo, and then it would show up and it would work. So I thought something is waiting to be hot enough to work. So yeah, I reflowed a bunch of stuff, and that seemed to make it worse. That seemed to make it not be recognised at all. Well, it would come up, Windows would recognise it, but it would say device unknown. So then we heated it a bit as it was plugged in, and all of a sudden it came to life, and Windows was like, oh yeah, there you go, there's your DAC. So we thought, okay, so yeah, it's silicon going out of whack, and you've got to heat it to get it to register. So then we had to listen to it, and it was distorted as heck. It was completely unlistenable. So the DAC chip was bad, and heating it sort of changed how it was failing. Oh no, Jordan, you didn't! I had 3 amps coming back, all of them using 1404s that you got from Alibaba. I have a great deal of luck for a few years, though, failed leak. Oh no. Dude, don't buy parts from AliExpress. Yeah, you might get some... Right, no. Actually, I don't really think that there's any genuine FETs on AliExpress. There might be some genuine FETs, like they're the genuine FETs, but they will be failed batches. There will be batches that didn't meet the specifications required for that part, so they're sold off cheap to these like sellers in Alibaba. So if you want to buy electronics parts, buy them from a reputable electronics supplier that's getting genuine parts, that supplies them in your country. Don't buy from China, don't buy from eBay, don't buy from Amazon, don't buy from AliExpress, anything like that. Because your chances of getting a either fake or a failed batch is like 99.9%. And even if they work, they might not be the right spec, and they'll fail if pushed hard, or they'll fail after a small amount of time or something. Right, so let's put this, oh here you go, this is what the front of the amp looks like, by the way. So this is the Audiosystem. I have a soft spot for Audiosystem because I love my Xion 15s from back in the day in the Proton. They're probably my favourite subs I've ever owned, actually, apart from, actually maybe yeah, even more so than the Pioneers. People ask me what are my favourite subs I've ever owned. Well, the answer is Audiosystem Xion 15s. Wish I never freaking sold them. I didn't realise how good they were at the time. But there you go. 4 fans on the top. Looks pretty cool, doesn't it? Alright, so yeah, let me grab this Audiolab home amp. Let's see what's crack-a-lacking with that. So we've got a bunch of spare parts here. Now, the cool thing about this, which I'll show you in just a minute, the cool thing about this amplifier, this home amp that I'm working on, is that I don't need to fully dismantle it. Because, if we take a little peek here, so this is the top of the amplifier. As you can see, got a linear power supply, just a transformer. It kind of looks a bit homebrew, to be honest. Look at the capacitors here. They're just kind of like zip tied in, and then the legs for the capacitors are just kind of like soldered to these wires that they can go into the board. Like it's a little bit homebrew, not gonna lie. But yeah, as you can see, we had 4 resistors there that were burned really badly and have damaged the PCB and the trace on top there. 2 transistors here that were bad. Got another 2 resistors over here that were really burned. We've got some resistors up here that were burnt out. What's cool though is it tells you the value of the resistor on the board. Like, yeah, it's pretty cool. And then we had some more over this side that were burnt as well. So yeah, quite a lot of damage. But like I say, the cool thing about this amp is we don't have to take it out of the case because the top comes off and the bottom comes off. So we can just do all of our work with it still kind of mostly in the case here. You just take the top and the bottom off. The reason for the failure was the owner of it was pushing it very, very hard, and it killed all the output transistors. So you got output transistors here, 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 and here. There's 4 output transistors, and the original transistors that this amplifier used are these. They're massive. They're basically like TO247 or TO3P, but they're like really wide boy. They are 200 watt parts, so they're much bigger in order to dissipate more heat. So that's what they used originally. Now, you can't buy these parts anymore. They don't exist. They are on eBay, they are on AliExpress, but as I've just explained, we don't trust those. So fortunately, time has gone on and silicon has improved, and you can fit parts to this amplifier that are the regular TO3PN size, that are about the same spec, equally as rugged, will dissipate the same amount of energy. So that's what are we going to do. But before we do that, before we look at the output transistors, we need to fix all the other crap. So basically, how are we going to replace them? Yeah, I'm just going to use some modern parts that are the regular TO3PN size. That'll be fine. The values and part numbers written on the boards blows my mind. Yeah, I know, right? I thought that at first. I was like, yo, what's interesting though, right? And I don't know which way to go with this. Okay, so the resistors here that have failed, these are marked 2 kilo ohm, 2 KO. Oh, the camera sucks, not gonna lie. But yeah, there you go. You can see they're marked 2 KO. So these are all 2 kilo ohm resistors. Same over here, and same on the other side. However, I did find a service manual for this amplifier on the internet. Let's see if I've got it in my downloads here. 8000, please be downloaded. 8000S. Here we go. Open with Firefox for now, because that's what we're using. So I'm going to show you the service manual. Okay, we're going to scroll all the way down to the board layout overview, which is just here. So let's zoom in on this, and you can see that in the service manual, okay, those resistors are actually marked as 3K. Can you see that? So the service manual has 3K there, and also over here where they failed, but my board has them marked as 2K. So I'm not sure whether to go with what the board says or to go with what the service manual says. I don't know which was made first. They don't have any dates on them. The service manual's not dated. This amplifier doesn't seem to be dated. I tried reaching out to Audiolab, but all of their emails bounced back. So yeah, I think I'm just going to go with the original 2K that's printed on the board, because that's what was in the board before, that's what works with this exact board, so I'm just going to go with the 2K. Okay, so let's get all of our new parts here. We've got a 546 transistor. Let's drop these in. No, so I checked all of the drive transistors in the manual, and everything else is exactly the same. The only thing that's different is these resistor values. So I don't know whether the service manual was made first, and then they decided further down the line, oh, hang on a minute, you know what, 2K would be better there, and they made it be 2K, or whether the amplifier was made first, and then they revised the service manual because they thought, oh, actually, you know what, 3K is better there. I don't know which way around it was, and I don't think we're really going to ever know unless we speak to them. And like I say, I can't get in touch with Audiolab, their emails bounce. And even if I could get in touch with them, I doubt I'm actually going to be able to get to speak to a technician that would actually know what the heck I'm talking about. Because this is quite an old amplifier now anyway. Split the difference and go with 2500, yeah. So these are 470s, so let's go up to where the 470s were up here. Let's drop these in. how's the stream going anyway, actually? How many viewers have we got? I've got 90. Oh, that's not too bad. Hey, oh no, wait, 110 a while ago. Heck, that's pretty cool. This is a relatively decent stream. Okay, let's continue. So those 470s, these ones over here are fine. We have a 22 as well there that needs to go down. I think that's just 122 that was bad in the center of the board there. And then we need our 2.2Ks that I'm going to go with. Those are the 3. I actually ordered 3Ks. Here we go, these are the 2Ks. I did order 3Ks originally because I had the data sheet, but then when I started pulling the amplifier apart, I was like, oh, hang on a minute, these are 2K. Don't think I've quite cleared all the solder from that hole, it doesn't want to go through. There's that one. Oh guys, also if I get this fixed relatively quickly, I can also look at, I forgot that I've got this here actually, I've got a, is it a KEF PSW 2010 home theatre subwoofer plate amplifier. That could be fun. Top of the MPSA 42 looks cracked, says Gary. Let's have a look. Which one are you referring to? There's probably quite a few. Oh, this one over here. Actually, you know what? You might be right. That is a very, very good spot. I don't think I'd really caught that yet. Maybe the camera makes that easier to see. That actually does look kind of cracked. Heck. Gary, you have the eyes of the gods, my friend, because that definitely does look a bit sus. I'm going to remove that and give that a quick test in the tester. Bloody hell. Go on, Gary. Nice one. Good spot. JBL Tester, what's up, my man? How's it going? You know what, Gary? I reckon Gary right there with that, the spot of that that cracked transistor. If it even is cracked, it might like look cracked but be fine. But anyway, if that is actually bad, that man's probably saved me a couple of hours there. Not gonna lie. I might not have even spotted that for quite some time. And where that transistor doesn't read short, because I've gone through this entire board and like looked for transistors that read low resistance or short or anything like that. I might not have actually spotted that for some time. So if that is bad right there, I would do you a reverse donation somehow there. Yeah, I'll have to employ Gary as my remote assistant, and he can do visual inspection for me. Okay, we're good to solder in those bits now, and I'm gonna go ahead and remove that transistor as well. See what that's saying in the tester. I really hope this one's not going to be paining as this repair here. Fortunately though, this amplifier, because it's got a linear supply, it's really easy to get up and running. Oh, I don't know if that comes through on the live stream, but my voice is resonating around in the heatsink here. That's crazy, yeah. It's like the fins are ringing with my voice. It's kind of giving this strange echo. I've no idea if that's even going to come through on the stream, but it sounds weird as hell in here. In general, best 10K amplifier. It's got to be the Powerus PW10000, my friend. Absolute monster. Really nicely engineered amplifier. This is Class AB, yes. It's a Class AB. Okay, just got a couple more 2Ks to fit, and then we can remove that suspect's transistor. Have you got a way to limit the current for the test? Yes, absolutely. I'll show you that in a bit. But basically, we're just going to inject rails directly into the caps here. The power supply and all the auxiliary supply voltages that this amplifier needs for the preamp and stuff is generated from the rails. So all we've got to do is give it plus minus like 32 volts. We can do that easily current limited, yeah, we should be good to go. A home amp's more difficult to repair than car amps? Nah, I would say, like, the thing with car amps is because car audio is kind of a crappy industry from a like product quality point of view. Most car amplifiers tend to be like copies of each other, or they're very similar to each other. There's not a great deal of variance in the circuits, so it gets quite easy to really learn the circuits and really know the circuits in car audio. Whereas with home audio, PA amplifiers and stuff like that, the variance in the circuit design can be very vast. They can be very different from one another, so the kinds of common failures from one style of circuit will be different to another. So I guess it's harder in that sense. But at the end of the day, it's an amplifier. Amplifier is an amplifier. The only thing that car amps have is a different type of power supply circuit. Okay, a little bit of isopropyl. Clean that up. Now let's pull this 42 out and see what it reads in the tester. So that was this one all the way up here, wasn't it? MPSA 42. So that is this bad boy right here. So let's pull that out and see whether it's actually cracked and failed, or whether it's just like a dodgy assembly of that part that looks a little cracked. Okay. Nah, that is proper cracked, you know. That really is. There's got a great big crack down there. Like, I bet you if I put this in the tester, it's going to read nonsense. Wow. Good job. Good going, Gary. Yeah, look at that. Oh, I never would have found that in the circuit. 79K and 76K. I never would have found that. Thank you, Gary. I mean, if I was having headaches, I might have done another visual scan over, but yeah, this is how things can fail differently in home amps versus car amps. In a car amp, you never really get that. I don't know why. I don't know why it's different. Maybe there's more current available or less current available. Something's different, but you never really get that. Let's see if I can crack it open. Can I crack it open, maybe? There we go. Oh, it's got such a tiny little die inside. Yeah, I'm going to check everything else that was around it. But there was some 470 ohm resistors that failed really close by. See these? So I guess I should be a bit suspicious of this. BC5568. Let's compare some measurements with it compared to the other channel. So 13 and oh, my bloody multimeter camera again. Nah, the multimeter cam's not happening, guys. It's like it's all over the place. So you're just gonna have to take my word for what I'm reading out. So we've got 1357 on this side. About the same over there. 1300. 646, 650, and that is open. And that is also open. And fit probes 652. Yeah, the readings between this part and its co-part on the other channel are reading the same. So yeah, I'm going to go ahead and just trust that for the time being. We've got all these diodes as well, which I have gone through and checked for shorts at least. But yeah, all the other ones look alright visually. Okay, so we need one extra part that I hadn't considered. MPSA 42. Let's see if I got any of those. I've got loads of them in surface mount size. MPSA 92. Nope. MPSA 42. There we go. Lovely stuff. Love it when the parts are in stock. Yeah, the reason the multimeter cam is not happy is because of this absolute nonsense USB tip that they put on. See, it's a combi USB-A and USB micro, but the way that the USB-A connects is it just rests these pins on these pads and it makes for the worst possible imaginable connection. So yeah, what we're going to do is we're just going to do this. Yoink! I've been wanting to do that for so long. And then we're just going to do this. Thank you, Reese, for this. Doesn't really work on small ones like this. But yeah, I'm just going to put a new USB end on this because fuck that. I don't know if I have any spare USB end with me right now, but I shall get one from the loft in due course. But until then, you've got no multimeter cam because I just cut the bloody end off it. Yeah, anyway, let's drop this in. MPSA 42. Assume that it goes that way around, yeah. I'm sure it probably is fine. There we go. Solder that bad boy in. Yeah, the board has fantastic markings, doesn't it? On the bottom and the top. Everything's marked as to what it is. Love to see it. Very good, very good. Very good, very nice. So, I could power it up now, but we don't have any output transistors in. So, I think it's time to drop some output transistors in place. I just quickly need to remember which ones I was going to use in place. What's everyone up to this weekend? Got anything planned? Any nice plans? Any shit plans? I made a note of which transistors I was going to use in the outputs of this. The only thing I've got to do is I'm either going to have to drill a new hole in the heatsink for where the new hole lines up, or use a little plate that clamps them together. Okay, which ones was I going to use? SA 2151 and 2SC 6011. 2151 and 6011. Fantastic. $21.51 and should be next to it. There we go. So yeah, these are my replacement parts. As you can see, they're a fair bit smaller than the originals, and they have a hole in a different place. But they're much more modern, and they'll be fine. Oh, they're chunky as well. These original ones are bloody massive, aren't they? Look at the size. Bloody hell. Anyway. Yeah. Does it mark on the board which one goes where? Should do. Seeing as everything else is bloody marked, isn't it? It's not marked on the top. Is it marked on the bottom? No, it's not marked on the bottom. Right, so which ones went where? Let me just quickly grab a picture that I took to remind myself which ones go. Where is my phone? I don't have my phone. Okay, no worries. Let's just log back into Facebook, because I'm sure I sent this nice gentleman a picture. I'm sure it was the SAs went here, and the 2SCs went here, but I want to be double sure. Has anyone else noticed that Facebook is doing this thing where it asks you to make a pin for your message history? And then you have to enter that pin every time you open a new browser or anything like that? Do you have a specific way of sorting, stocking, cataloguing parts? No, I just buy parts and I just put them in random drawers, and I can never bloody find which ones are where. And I've started to label some of them, but most of them aren't labelled. It's a bit of an ADHD mess, to be honest. I was watching your huge 23Hz bass. That video made me want to put subs in my room when I was a kid. That was a pretty good video. I was quite happy with that one. Right. Let's see. Do I have a picture? Nope, I didn't send this gent a picture. Lovely. So I'm probably going to have to go and find my phone to figure out which ones. Oh no, wait on a minute, I've got the data sheet, haven't I? I have the service manual right here in front of me. What am I talking about? Right. Surely it tells you on the service manual. No, it just has Q717, Q718. Doesn't actually tell you which one goes where. Hang on a minute, one of them's got a star next to it. Does that mean that that's like NPN or PNP? So the MPSA92 has a star. MPSA92 has a star. BC556 has a star. So that must mean PMP. BC556B. PMP. So the ones that have a star next to them are PMP. So that means, that must mean that these ones with the star are PMPs. And the ones in the middle are NPN. That's what that must mean, surely. That's what we're going to roll with for now. Is it written at the edge of the page? I don't know. Let's have a look. If I Control F Q717, let's try that. Q717. No, not found. That's stupid, isn't it? Why would they do that? Well, they made this amazing data sheet, this amazing service manual, this amazing amplifier, but then nowhere listed is which output transistor goes where. Right, so like I said, what I'm going to have to do is probably drill a new hole in the heatsink to put the screws through for this. Either that or get a plate to clamp, get 4 plates to clamp either side. I'm probably going to drill a hole. I think that's going to be easier, to be honest. I think I left the screwdriver downstairs as well, so you might have to bear with. These are the screws that came with it. 1, 2. I should have one more as well. So yeah, I just need that to go through there. So I'll drill a hole that way and drill a hole that way. Problem is I've not got much clearance. So in order to drill a hole, I'm probably going to have to remove this heatsink piece so I can actually get at it like from a decent angle. So yeah, let's remove the heatsink, I think, so I can actually get a drill in there. David says mark the holes first. I don't think I need to mark the holes because I've got the height based on the other two holes that are next to it, and obviously the part isn't going to be soldered in, so it can just it can line itself up with the holes and then solder in that location. So I think I'm alright. This is slightly too big. Evening to Brett in Nottingham. Thanks for jumping on the stream, buddy. Appreciate you coming on. Yeah, the long box in my room that I did that video to was tuned to, I think it loaded the port the most at like 17 Hz. It was ridiculous. Really good fun, that. What about a power up test with signal? I did think to fit the transistors before clamping them to the heatsink to power up and just test with some signal, but that would kind of be a pain in the arse to then get the holes drilled and lined up. So there we go, heatsink's off, nice and easy, just a few bolts. So yeah, we just need to drill a hole. So the original transistors went like that, and the new one I'm going to want is going to be slightly above there. So I could just mark that, couldn't I? There we go. Get my little spiky tool. Mark that there. And then same on the other side. Thanks Joe Repair, I appreciate the kind comments there. I would argue that my videos aren't necessarily always that well made. It's kind of slapped together. Boom or Bust was good. Boom or Bust is some of the few videos that I've actually put an effort into the production value of and stuff. Right, I do now need to go and get my drill. So bear with me. I shall be back in just a moment. I've left it downstairs, I think. Oh, wait, what have I done with the drill? Oh no, no, it should be in here. Ah yes, it is still in here because I was using it for the three-phase motor test. I don't need to go anywhere, it's right here. Fantastic. So let's find a drill bit that's the right size. A bunch of drill bits up here. That one, is there much play in there? No, it's like tight. Slightly bigger. Berries, do you have a dim bulb tester? No, so I'm not going to connect this to the mains when I test it because you can inject the rail voltage to this amplifier to test it. So I'm just going to inject some nice low current rails to test this one. Where's all my bloody drill bits gone? I need a little bit smaller than that one. Well, that would probably do. It's a little bit bigger than the original ones, but that one's maybe a little bit small. Let's start with the small one because we're doing metal, aren't we? So I'm not going to drill over the amp because you can have metal shards might go into the board. So let's pop that down for a minute. Do you have a symmetric power supply? Yes, sort of. I have a car amplifier with a bipolar rail supply, so yes. Basically, yes, it's a switch mode power supply that generates plus minus anywhere from 25 to 50 volts rails. So thanks, Exiode. Appreciate the comment, my friend. So let's go straight in here. I do actually have some drilling and cutting oil. Maybe I should use a bit of that. Seeing as it's right here on the bench. There we go. Well, it seems that this drill bit sucks. I've barely made a freaking dent. Okay, this is going to be fun. This is only aluminium, isn't it? It should be easy. Maybe this drill bit's just screwed. It's like not doing anything. Okay, maybe we'll go in with a smaller drill bit first and then widen the hole with this one, because I think this one might be a bit screwed, a bit blunt. Send me your address, I'll post you some proper drill bits. I appreciate that, man, but unless you're in the UK, it's going to cost you more than it would cost me to buy. Drill is not in reverse. Oh my god, that's better. All of a sudden, instantly drilling. So yeah, that other drill bit must have just been blunt AF. There we go, we're through. So that's the small hole, and then I'll have to go and make it a little bigger with the larger blunt drill bit. But because there's a hole there already, it'll be way easier. Just going to pull these thermal pads off. Probably should have done that already, just to prevent metal shards getting in them. It's a heat sink, yeah, it's a heat sink. Oh, that was a long spirally boy. Guys, check this one out. Wow. That was a proper long spirally boy. Love that. That's cool, that is. Alright. So now we need to open it up a bit more with the blunt drill bit. Crip Skills, that's the one, my friend. Oh guys, so drilling ASMR. One thing I love about this drill, okay, isn't how good it drills, but the steps on the speed controller are musical notes. I don't know if that was done intentionally, but as you depress the trigger, it's not a linear analog speed controller. It's like steps, digital steps. So I don't know if this will come through on the stream, but I'm going to increase the speed, and it sounds really like every speed increase is like a musical note. It almost sounds like a pentatonic scale or something. So there you go, there's some drill ASMR for you, or drill music production skillage, I don't know. Anyway, let's make this hole a bit bigger now, shall we? Go on, you should be able to do this, there's already a hole there. Bro, this drill bit is so blunt, it can't even drill through a hole that's already there. Nobody knows says that's the cheap speed controller, newer ones don't do that. Oh, really? Interesting. I like it. Oh my gosh, this is the most frustrating thing. I think we're almost through. Finally! Finally we're through, oh my gosh. That drill bit is just the worst. Right, let's see if that's big enough for these bolts. Oh, it's just a touch too small. Right. Like I could tap, like it's just the right size where I could tap this hole with this bolt. But I don't know if I can be asked for that. Let's go one size up. What's the next size up? Is that this one? Might be this one. Yeah, there we go. This is one size up. This should be fine. Maybe this drill bit will actually be half decent. Oh, it's like it's there. It's like I might just If I wiggle this around a little bit. Yeah, it's like halfway through already. Yeah, I'll just screw it in and it will like marginally tap this hole and it'll be fine. I'll tell you what though guys, I freaking hate this stuff. Like I don't like the old making stuff and like tools and shit. I just want to repair electronics, you know, but sometimes when you're repairing electronics you've got to do the stuff with the tools and it's like ugh. Oh my god, look at how quickly look at how quickly that went through compared to that black one I was using. Oh my gosh, I need to throw that in the bin. It's probably still good for wood, but oh my days. Dude, this just like literally just chomped through it in like a second. Whereas that black one I was like reeing on it for like a good 3 minutes. Alright, it's just widening that out a little bit more. Okay, cool, so we've got 2 holes now. I might actually just tap them while the heat sink's out, just to make life a little bit easier for me when it comes to putting it in the amplifier. So let's. I think that's going to be that size, isn't it? Yep, that is. Tony says this was painful to watch. Dude, trust me, I'm going to be watching this back later like, whoa! I'm not a fan of this type of work. There we go. Super easy. I'm not a machinist. I'm not a person who does metal. Give me a circuit board any day. There we go. So we're not really tapping it because the hole is just too small. Yeah, so it's like, you can see it's not really tapping it because the hole is like almost the same size. That's what I wanted. I wanted it just to slip through. But the next drill size up would probably be too big. So I'm not tapping it as per se. I'm just like making sure that it goes through nice and easily. So when we put it back in the amplifier, it's not going to be really hard to screw in at a weird angle. So. Right. Yeah, actually what I'm going to do is I'm actually going to, might as well, attach the new transistors to the heatsink while we're here, and then we can just drop the whole thing in one go. So if I can remember which way round this was, that was there, transistors, so I think it was the 2 A's on the outside, wasn't it? I'm pretty sure it was the 2 PNPs on the outside and the 2 NPNs on the inside. The 717 is the PMP. It says is. Let's have a look. 717 is PMP. Yep, that is the 2SA. Pretty sure. Okay, now we just need a little washer and a nut. Need 2 washers. Need a flat washer first, and then a spring washer, and then a nut. The isolation pad doesn't make sense if you put a screw through it. Well, the transistors have. The metal doesn't go all the way to the hole. So basically the screw is fully insulated against the tab through the hole. Only on these larger package. With the smaller package TO220s, that's not the case. So with the TO220, it's not insulated from the tab, the hole. So you need like these little plastic insulatory things that are a pain in the arse to use. The reason you couldn't find it is because it's written Q717.718. Oh, okay, it's written like that, is it? In the list of components. No worries. Stuff and things, love a stream, Sam. I hope you're doing good. I am doing good, thank you, my friend. Thanks for jumping on. Appreciate that. So we have a C. I'm actually probably going to put the screw through the A just in case I need to, for whatever reason, take it off at some point. Okay, and then that goes in there. I think this hole is ever so slightly smaller, so I just need to screw her up. That actually screws down pretty tightly, that one. Not that that really matters, because we're going to put a nut on the other side anyway. Once again, we need a flat washer, a spring washer, and a nut. Alex the Amp guy. Yeah, that's quite funny. It's a bit like how truck drivers will spend like do a 10-hour shift driving a truck, and then they'll come home, crack open a beer, and play Euro Truck Simulator. Okay, cool. There we go. There is our new transistors on the heatsink. So let's get it back in the chassis and solder them up and see what it's saying. This is going to be fun, getting all the legs lined up with the holes. Got 12 legs to line up at the same time. There's 1, 2, 3. Probably get some tweezers. The others, 4, 5, 6. 7, 8, 9, 10, 11, 12. Nice. In you go. Now, don't be falling out anytime soon, please, because I just got you lined up. Yeah, that's right, this is a mains amp. Although we're going to power it like a car amp. We're going to use a car amplifier to generate the rail voltages for it so that it's nice and safe. Low current tings, you know. Okay, solder these legs in, and then we can hook it up. He collects rare transistors. He's saved me many times. Yeah, I'm sure he has. That's cool. I think you should disconnect transformer. No need to disconnect transformer. We're just going to inject some rail voltages. And we'll be injecting the rail voltages after the rectifiers, so no need to disconnect the transformer. This is an Audiolab 8000S home integrated hi-fi amplifier. The customer was using this at loud, high volumes, and it just turned off, and it turns out it burnt loads of stuff in the amplifier section here, so good fun. Okay, so now we're ready to inject some rails and see if this thing makes any audio or not. There could still be problems, there could still be issues in the drive circuit. We could still have transistors that seem to read fine in circuit but actually are screwed. So, in order to get this up and running then, we're going to inject some rails. And to do so, we're going to use my little 12 volt current limited setup here. So I've got a 12 volt power supply that's fully current limited. And this right here is a little piece of junk car audio plate amplifier. It's an MTX Road Thunder. It's a little Class AB amplifier with all the output transistors and stuff removed. However, it still creates rail voltage, so we can use this to create some bipolar rails. Looks like we're going to be generating, the rail capacitors of 50 volts. So we're going to be generating, we're going to be able to set this to about plus minus 32 volts, which is what this amplifier wants. So yeah, let's get this thing connected up. And let's get some rails connected. 0.7% THD isn't actually that low. I'm sure you have claims of much lower THD from other similar hi-fi amplifiers. Or 0.07, yeah, 0.07 THD. That doesn't seem that low. I can't remember what the Technics SUV series amplifiers were, but I'm pretty sure they were like 0.0000 something. Anyone familiar with the GZCA 6000? Yes, Bass Starlet. What can I help you with? If you're asking should you buy it, the answer is absolutely no. It's a pretty bad amplifier, that. Wouldn't buy that. Okay, so we got power going in. And what about remote? That remote's just jumped off of there. Let's pop that up there. We can adjust our rail voltage to suit this amplifier. By increasing or decreasing the voltage. So let's turn the power supply on. Start off at like 9 volts and let's see what rails we get. With 9 volts worth of input. And gets excessive current draw for some reason. What have I done wrong? Did I do something wrong? This worked last time I used it. What's going on? What have I done wrong? Is there a little solder bridge or something? Sorry guys, just a little bit confused right now what I've done here to make this not work. Remote goes in there, yep. Yeah, we're going to do the bias as well on this. I'll need to turn the bias down to 0 actually. Good call on that. Huh, it works fine now. Eh? I'm not sure what I did, but I did something and now it works. Anyway, let's pop that back up there. There we go, okay. So, rails, we have -26 and +26. So let's increase that a little bit until we get to, I think it's 32 that this wants in the service manual. 31, 32. There we go, you can see it on the scope screen there. Negative 32 volts on the negative rail and positive 32 volts on the positive rail. Cool, so that's 11.6 volts worth of input gives us those rails. Muy bien. Let's just double check with ourselves that that is what the service manual wants. 32 volts. Was it 32 or was it 33, 30? it says it's somewhere in here. It's like, oh yes, to power this up you just inject some rails into here and then it's all good to go. Here we go, this is what it says. Oh, there we go, 32 volts, yeah, 40 milliamps it should be per rail. We're not going to be able to see that exactly, but I don't have a nice high voltage tracking supply like this, hence why we're using the MTX, but that's fine, does the same job. So we're going to plug our rails in, so that's going to be our negative rail I assume, the black, and the red's going to be our positive rail. Let's just check the data sheet. Yep, red is the positive rail and black is the negative, and we also need a ground reference as well, so I'm going to tack a ground onto there as well. So yeah, let's go ahead, and I don't have crocodile clips for these, so I'm just going to quickly solder these leads on. Let's just check which one's positive rail. These wires don't seem to have any identification on them, which is fantastic. Well, one of them is a square, so I assume I made the square one be positive. That would make the most sense, wouldn't it? Yep, I did. I made the square one be positive. Cool, cool. There we go, little discharge. I think I'm actually going to start off with much lower rails than it suggests, just to monitor the current draw as the amplifier comes to life. I think the lowest I can go is like 9 volts or something on the power supply for this little amplifier that we're using to inject rails with. A little bit of flux on that one, a little bit of flux on that one. I'm going to tin them with some fresh solder on these rail caps so that it sticks nice and easy. Go. And there we go. Square one on the positive. Square. And a round one on the negative. Yep, all good. And then we just need to connect a little crocodile clip to make a ground reference that matches the amplifier, the supply ground. So I'm just going to clip a little ground lead onto my oscilloscope probe here. That will form enough of a ground connection for this quick little low current test. There we go, clip that on there. Lovely jubbly. Just double checking that I made that common ground be common ground. I think it is. Pretty sure. Okay, so let's start off nice and low, and this is the moment of truth. See what happens with it. And make sure there's no solder or anything on the bottom here that can short out against the underside of the board. Okay. And just before we go any further, let's turn the bias potentiometers all the way down to 0. We assume that anti-clockwise is down on these. Yep, there we go. Bias is down. Start off nice and low. Please don't anything burn. Current is super low as well. I'm just going to probe the speaker terminals, I think, just to make sure there's no DC or anything on there. Let's go. Okay, well, we're drawing over 3 amps there. This little amplifier thing that I've got up there only draws 0.3 amps at idle. So this whole output section here was just drawing over 3 amps, and it was knocking the voltage down really low. So why is that? Is something getting hot on the main board here? Well, let's see what the rails are going to. Going to about 13 volts there. How about negative? About 13 again. Okay, let's take out the thermal imager and just see if anything is taking any heat. Ah, whoa! Something gets super spicy down here in the middle. That looks like it's going to be my 22 ohm resistor. Down there gets mega spicy very quickly indeed. Let's just spray some isopropyl alcohol on there and confirm. Pretty sure it is. I think I saw that just evaporate a little bit from there. It's kind of hard using the isopropyl alcohol method when you've got through-hole components. Okay, so there's likely to be a transistor or something that's out over here. Or is it one of these other ones in front? It's very hard to tell. Okay, let's just check if we have any DC going to the speaker terminals while it's doing that. So that 22 ohm in the middle there is getting cooked. But I just want to see if any DC appears on any of the speaker terminals here. Okay, we have like something. Yeah, got some noise on that channel. Same on both. Okay. Is there anything else getting hot other than that resistor? Yeah, looks like something over here as well. Is it this transistor maybe? No. Maybe a resistor around this area? I think a resistor around this area, so we might want to turn our attention to this circuit a little bit more. How about over here? Okay, nothing getting warm around this side. So it seems to be mostly there in the middle, that 22, and over here, something over here is getting warm as well. And this was the side that had the bad 42, MPSA 42 transistor. So I suspect there might be some other stuff around here that's kind of bad. Let's just check the circuit a little further back this way as well. Okay, nothing else hot in the circuit around this area, so yeah, I'm going to turn my attention to this area over this side here to see if I can quickly find something. It's quite late now here in the UK, so I'm probably not going to stream for too much longer, but I just want to take a peek, see if there's anything obvious. 760 and 460 on that big one. 450 and 740, yeah, that's correct. And nothing that way around. That way around. 11. Okay, there's a bit of a difference. Yeah, okay, there's a difference. 19 that way around. 15 that way around. So yeah, there's some differences on this A42 that I replaced. So it might be other bits and bobs around the circuitry for that. That is a 627, and that is similar. So there's different readings around this here, around this circuit. 1957 on this diode, 1537, okay, yeah, I am suspect of quite a few parts around here. I think I did also replace a 1M1418 over here. Sorry, 4148 over here as well. These two here. That one there. I could pull up these drive transistors and check these as well. And also this transistor, this 556B. Okay, so we've got a little bit more work to do on this one, but I think, gents, it's been a pleasure. I'm going to leave it there for tonight. We're going to take another look at this one maybe over the weekend or next week, and yeah, see if we can identify the problem in the drive circuit for that channel that's causing all that stuff to get hot over there. There's a bunch of ways I can attack that. I can see what's connected to the 22 ohm that's getting hot. I can start pulling parts around this area of the drive circuit. There's not too much stuff around there. You could just pull stuff and read it in the tester and go from there. So yeah, not too difficult, I don't think, to diagnose that further. It's going to be pretty interesting. I did try the bias potentiometers both ways, like fully one way and fully the other way, and didn't make any difference. It was super high current draw anyway. Check the voltage over the emitter resistors. Yeah, that's not a bad idea. I'm just going to quickly check the resistance actually across the emitters. Oh wait, hang on a minute. That emitter resistor is open. Ah, I don't think that would cause the high current, but that one's not. But it does seem to be quite high resistance. Okay, I need some 5 watt 0.22 ohm. Oh no, hang on a minute. This is K. Hang on a minute. These are the emitter resistors, aren't they? Yeah. This one's 0.22 ohm. So that one's open. I wonder whether that would actually cause an issue. Maybe it would, but yeah, got an open emitter resistor there, so I need to probably order some of those because I doubt I have 5 watt 0.22 ohm resistors. So That's another thing. Thanks very much for for pointing that out, Oliver. I hadn't actually thought to check the emitter resistor. They were just kind of hiding there. Like, I know they're pretty big, but like there's different package that I'm used to seeing, so I just kind of glossed over them. But yeah, need to order some of those. But yeah, I appreciate you guys jumping on the stream. It was really fun to chat to you guys. Nice first stream of 2024. I always say this, but I want to try and do some more streams as the time goes on. So I hope you have a great rest of your day, and I hope you have a great weekend. And yeah, I shall catch you in the next one. Thanks for everyone that chatted and gave a heads up on some issues as well. So yeah, I'll see you in the next one.